My screen okay?
Yep.
What's X?
1 sec. Sorry.
First of all, let me tell you that whenever you're solving a right triangle, the side you are solving for is always the square root of. That's the very first words that should be out of your mouth, is the square
74.
root. So what is it the square root of?
8.6.
No, give me, I don't care about decimals. I want to know numbers. In other words, it's 5 squared plus 7 squared.
Yeah.
Okay, what is that? That's the square root of 25 plus 49, which is the square root of 74.
Yeah.
Can that be reduced?
Not into a full number.
No, it really cannot be. In other words, square root of 74 is the answer. There's no way to reduce that. So that's the square root of 74. It's not divisible by 4. It's not divisible by 9. It's not divisible by 16. Any of the numbers that you would typically expect it to be divisible by. Solving right triangles is unbelievably important. What's X equal to here?
9. So you do 3 squared plus x squared equals 5 squared, right? So
correct, but the way I want you to remember it is different than that. I want you to remember it as x equals, and it's always the square root of 5 squared minus 3 squared.
Oh yeah. So 25 minus 9.
Okay.
16.
Okay.
And then the answer would, x would equal 4.
Correct. Now, this happens to be a very special triangle, a 3, 4, 5 triangle.
Yeah.
Okay, but it still has to follow the Pythagorean Theorem. Okay, so what if I made this number 6? What's x equal to? Always start with square root of.
It would be 27. But
Well, hold on. I want you to give me your answer like this. Okay? That is 27. But I don't know that you understand it until you give me your answer like that. In other words, that's 36 minus 9, which is the square root of 27. And simplify that. What is the square root of 27 equal to? In other words, this is one of those numbers that you can simplify. You can reduce it.
You can?
Yeah, what are factors of 27? What two numbers multiplied together?
9 and 3.
Okay, so I can say that's the square root of 9 times the square root.
Oh, yeah.
And then the square root of 9 is 3. So this is actually our final answer.
Yeah, I remember that.
you would never, ever give that as an answer in mathematics.
Mm-hmm.
Okay?
Or for...
In other words, you always simplify if you can. So this side is 3 root 3. It isn't square root of 27. Now, if you put those two numbers into a calculator, you'll get the same thing. The square root of 27 is the same as 3 square root of 3. But there are certain conventions you have to obey in mathematics. And one is that you do not ever represent a number unless it's simplified.
Mm-hmm.
So I never would ever give an answer of square root of 27. I would always reduce it to 3 square root of 3. What is X and what is Y?
X would be...
Hold on. Let
It's a 90-degree angle.
me make it a little simpler.
Well...
What is the unit triangle that is similar to this? In other words, for two triangles to be similar, they have to have the same angles.
Mm-hmm.
What are the dimensions of the unit triangle? You just have to remember this, Daniel. I hate to keep harping on it, but if there's ever anything that you want to memorize, it's this. What side is opposite the 30-degree angle? What's the dimension of that?
Well, it's 30, 60, 90.
Right, but I call it my unit triangle. So what is opposite the 30 degree? 1.
Oh.
That's why it's called unit. Okay?
Yeah.
And this is square root of 3, and this is 2. And that's just something you have to memorize. There's no rhyme or reason on it. In other words, if you know that it's square root of 3 there, you can figure out that it's 2. But it's better if you just memorize these 3 dimensions. And I cannot express the importance of knowing this right here. All of it.
Mm-hmm.
It's the similarity ratio between these two triangles that are similar. How much bigger is every side of this triangle compared to every side of that triangle?
3 times.
Okay, good. So, what is Y?
Y would be 3.
What is X?
3 square root 3.
Perfect. I can't believe how happy I am that you knew that. That's a huge thing. Notice that these triangles...
I just needed a refresher.
Well, but notice these two triangles are exactly the same, only one is bigger than the other. And every side is 3 times bigger than the side of the unit one. So if you know the unit triangle sides, you can always figure out the sides of the bigger triangle. Okay? I'll give you another example. What is y and what is x?
Y would be...
First of all, you always have to answer the question, what is the similarity ratio?
Yeah. Oh, well...
What is it? Here. How much bigger is the bigger triangle versus the smaller triangle?
Oh. Like... 3.5 times?
Yeah, you know what? I prefer this answer. That is 3.5, but when we're talking about triangles, what we care about are ratios. Okay? Saying
Yeah.
3.5 doesn't help. Saying that it's 7:2 ratio helps a lot more.
Yeah.
What does that make y? What is y?
Y would be... Wait, sorry. Y would be 3/2?
Yeah,
No.
well, almost.
Well, 2 square root 3.
Multiply the similarity ratio by that. What is 7/2 times 1?
Say 7/2.
Yeah. So that's what that side has to be. Now, what is
Oh.
x?
Okay. And then the bottom would be 7/2 root 3.
Good. I like that you answered that way. And that actually is as simplified as it gets. In other words, I cannot simplify that more. That's the answer. So the secret when you're figuring out 30, 60, 90 right triangles is to figure out what the similarity ratio is and then multiply it by whatever the dimensions are on my unit triangle. Okay, let's do another one. I'm going to draw the unit triangle for the 45, 45. Notice that the sides opposite the smallest angle are always 1. Get you started. Now I'm going to draw another triangle that is similar to this, only it has different dimensions.
Yeah.
What's the similarity ratio? First of all, which is the bigger triangle?
One with the 5?
Yeah. I mean, square root of 2 is 1.4. This is 5. That's bigger than 1.4. So what is the similarity ratio?
5 root 2?
5 divided by root 2.
By root 2, yeah, that's what I meant to say.
Okay. Now, what's y? And what's x?
Y would be 5 and x would be 5.
Well, now hold on. You take your similarity ratio and you multiply it by that to get this. So what is this side right here? Anything multiplied 1 is what?
1.
It's the same thing that it is. It's
yeah.
5 divided by root 2.
Oh, okay.
Okay.
So then the bottom would also be
Yeah,
5 divided by root 2?
always, yes, exactly. Now, let's talk about something. If I have a number that is this, I don't ever give an answer like that. Mathematicians hate dividing by an irrational number. Remember that. You never want an irrational number in the denominator. And I can always multiply any fraction by the number 1. Well, what if I multiply this by this number 1? Square root of 2 divided by square root of 2. I don't change the value of the fraction. What do I get as an answer?
1 root 2 over 2.
Multiply numerators, multiply denominators. Yeah, I'm sorry, you did that. So you get that.
Yeah.
Now, the only difference in this, if you were to put this into your calculator, either one of these, you get the same number. In other words, 1 over root 2 is the same as root 2 over 2. Because you do not change the value of a fraction by multiplying it by 1. And remember, what I did was multiply it by 1. That's what I did. Okay? The only reason I did it was because mathematicians hate dividing by irrational numbers. Well, now I have the irrational number in the numerator, not the denominator. So, and it's difficult to explain why that is, why mathematicians hate dividing by irrational numbers, but just accept it and know that you can never have an irrational number. So what if I came up with an answer like this? What would you do?
Multiply both sides by root 3.
Yeah, both top and bottom by root 3.
Yeah.
It's the answer.
Root 3 over 3.
Yeah. Perfect. That is a legitimate mathematical answer. Okay? Now, there's something I want to impress upon you that may not be obvious, but if I have an equation, notice that, equal sign. That's an equation.
Yeah.
I can do anything I want to the left side as long as I do it to the right side.
So I can subtract 3 from both.
I could trim its eyebrows on the left side as long as I trimmed its eyebrows on the right side. Okay? That's very, very different than a fraction. When I have a fraction, I can only do one thing to it. I can multiply it by 1. Okay? Well, when I have a fraction, I'm going to multiply it by this 1. Notice that that's the number 1. And it gives me root 3 over 3. But there's a very huge difference between multiplying both sides of the equation or doing something to one side and doing it to the other, and multiplying a fraction by the number 1. Those are not the same things. In other words, in this equation, because I have an equal sign, I can do anything I want to the left side as long as I do it to the right. Well, I'm going to subtract 3, so I'm going to get x equals 7.
Yeah.
Okay, so that's fine, but know the difference. There's two different things. One thing says you can do anything to the left side of an equation that you can do to the right, and as you go higher in mathematics, you'll realize that that covers everything. You can take logarithms of the left as long as you take logarithms of the right. You can square the left as long as you square the right. You can differentiate the left as long as you differentiate the right. In other words, there's almost no limit as to what you can do with an equation. But with a fraction, there's all kinds of limits. I can only do one thing to this, which is to multiply it by the number 1. What number 1 would I multiply this by in order to rationalize the denominator?
Root 7. Yeah.
Root 7 over root 7.
Yep.
Notice that that is the number 1. And then what that gives you is multiply numerators, you have 2 root 7. Multiply denominators, you have 7. And that's your final answer. And that's an acceptable answer because the denominator does not have a rational number. Let's talk about rational numbers for a moment. What's a rational number mean?
Uh,
Let me give you some numbers and you tell me whether they're rational or not.
okay.
Is 1 rational?
Yes.
Yes, because I can write it as a fraction. That's the definition of rational. Can I write it as a fraction? How about number 2?
No.
Yeah, there is no fraction that represents pi. I can come close. I can do this. That's close, but it's not pi. Okay? So there is no fraction that I can write, no matter how many places, that represents pi. How about square root of 2?
Yes.
No.
No?
No. That's equal to like 1.41, but then it does not repeat. And in fact, square root of 3 is irrational, square root of 5 is irrational, square root of 6 is irrational, square root of 7 is irrational. All of those are irrational because I cannot write them as fractions.
Yeah.
In other words, square root of 3 is approximately 1.71, but there's a lot of decimals. It's like pi. It just goes on and on forever. In fact, any square root of any number is irrational unless it's a perfect square. What's the square root of 4?
2.
That's rational. What's the square root of 9?
3.
What's the square root of 16?
4.
These are all rational. But the moment I say square root of 5, that's irrational. In other words, if it does not come out to a perfect square, it's irrational. Okay?
Mm-hmm.
So that's the difference. There's not any square root that does not reduced to a perfect number is irrational. In other words, if I said that, that's got to be irrational because it's 5 and change. Okay? And I could even say that that's square root of 13 times square root of 2, but that's irrational and that's irrational. So square root of 26 is irrational. But any square root that is not a whole number, well, not quite. What's this?
Um, 3/5.
Yeah, that's rational. In other words, I can write that as a fraction. 3/5. So this number is rational. That's the definition of rational. If you can write it as a fraction, it's rational. Pi, there's no way I can write that as a fraction. It's 3.14595 ... goes on forever, never repeats. Okay? So there is no fraction that equals this. The closest you could probably come is 7/22, but that's not really even close. If you put that into your calculator, you will not get that. Pi is a special number. Another special number is E. E is equal to 2.71 ... The two most special numbers in all of mathematics are pi and E. All right. Let's end it there.
Alright. I think it was good again.
Yeah. No, I think this is helpful. We'll get back to geometry. I'm not trying to ignore geometry, but there's some algebra that you really have to know before you can get proficient at geometry. All right, Daniel, I will talk to you next time.
Okay. See you later.
Bye-bye.